Our next topic is relating to finding the area of an arbitrary triangle. And in analyzing or trying to find the area of an arbitrary triangle, we will make use of analysis that we've encountered in estimating or finding angles and sides for a regular triangle. Let us assume that we have this triangle here. We call it triangle T. This triangle had three vertices: vertex A, vertex B, and vertex C. And we are asked to find its area. One approach we can take is to draw a perpendicular from one of the vertices to the opposite side. So here we draw a perpendicular from vertex A to side A. And we are going to indicate this perpendicular with this symbol. It indicates that the angle that this perpendicular makes with side A is 19 degrees. We are going to use this to our advantage. Now, our triangle, the original arbitrary triangle, has been split into two triangles, T1 and T2. But if we look carefully, both of those triangles are right-angle triangles, where one of the angles is 19 degrees. Let us apply this also to the other triangles on this viewing graph. Let's say this triangle here, we are going to have vertex A, vertex B, vertex C. We could draw a perpendicular from vertex B onto side B, and again we observe that this triangle is made up of two right-angle triangles, T1 and T2. Let us now analyze the same triangle by drawing the perpendicular from vertex A onto the opposite side A. And now somebody is going to say, wait a minute. The side A will not intersect the perpendicular from vertex A. So what we are going to do, we are going to extend side A until the perpendicular from the vertex intersects the extension. And now what we observe is that we have two triangles that we will work with, but unlike the previous two cases where the total area was the sum of T1 and T2, in this arrangement we will have the total area being or estimated as the area encompassed by vertex A, vertex D, and vertex C, minus the area encompassed by vertex A, vertex D, and vertex B. Again, we formulated right-angle triangles, but instead of adding those triangles, we are subtracting these triangles. So the next step will be to understand how to find the area of a right-angle triangle. So we've seen that the area of arbitrary triangles could be easily evaluated as either the addition or the subtraction of areas formed by forming right-angle triangles. We will discuss how to find the area of a right-angle triangle. In this example, we have the right-angle triangle with angle gamma being equal to 19 degrees. What we will do, we will draw a line parallel to side B from this vertex up here. And then we will draw another line parallel to side A from the opposite vertex. And the intersection of these two lines will be 19 degrees, the angle included in those two lines. So what do you observe now? We observe that we have a rectangle. Given by vertices A, B, C, and D. The area of the rectangle let's call it AR, as we know, is the product of the lengths of two perpendicular sides. So in this case, it will be the product of A times B. But this rectangle is bisected or is split into two with the hypotenuse line C. So if it's split into two, the area of the triangle will be AT will be equal to the area of the rectangle divided by 2, which, if we take it to the next step, is going to be the product of the perpendiculars divided by 2. So the area of a right-angle triangle is evaluated as the product of the perpendiculars divided by 2. And of course, from our previous analysis on triangle analysis, we do know how to find the lengths of the perpendiculars.